You know, in the world of computing, we're always obsessed with making things bigger, right? More data, more power, more everything. But what if the next giant leap for AI actually comes from making things way, way smaller? That's the wild idea behind the 4-bit revolution. And trust me, it's about to change everything. So here's the massive problem we're all facing. The huge language models that power pretty much all the AI we use today, they are unbelievably expensive. They're power hungry, they demand a ridiculous amount of memory and computational muscle just to exist. And as these models get smarter, the costs are spiraling out of control. It's becoming a real bottleneck, threatening to slow down the whole AI party. We desperately need a new way forward. Okay, to get how we solve this, we need to talk about something called numerical precision. For a long time, the industry standard has been this format called BF16. The best way to think about it is like a giant, super high-resolution raw photo file. It's got all the detail, every last pixel, but man, is it huge. The alternative is this new low-precision 4-bit format, and that's more like a compressed JPEG. It's way smaller, way more efficient, but you always run the risk of losing important details. So the big question has always been, can you actually run a super complex AI on the equivalent of a JPEG without it, losing its mind? And that is where the story gets really interesting. A research paper, brilliantly titled FP4 All the Way, finally gave us the answer. It laid out a step-by-step recipe for training AI using this super compressed 4-bit format, something that, honestly, most people thought was pretty much impossible. Now, what made this a true breakthrough was that it worked across the entire training process. I mean, people had tried using 4-bit for little bits and pieces before, maybe for the model's weights or its activations, but this was the first time anyone pulled off a fully quantized training run, squishing down not just the weights and activations, but also the gradients, the very signals the AI uses to learn. All three. That was a huge deal. So the paper explored a few different ways to actually build this 4-bit format. And it turns out the industry was thinking along the exact same lines. Nvidia's new hardware actually supports two competing flavors, MXFP4 and NVFP4. As you can see, they use the same basic ingredients, but they differ on the block size and the scaling format. And that raises the obvious multi-billion-dollar question, which one is actually better? Well, the researchers put it to the test, and the results were pretty striking. They found that as you shrink the block size, that's the chunk of numbers that all share one scaling factor, the model's accuracy goes up. But, and this is the key, there's a sweet spot. The improvements start to seriously flatten out once you get below a block size of 16. So, what does that tell us? It means 16, the size used in NVFP4, gives you the best bang for your buck, the best accuracy without a ton of extra computational work. But look, the format alone wasn't enough. When you're compressing numbers this hard, tiny little errors can add up and just totally derail the training. So the paper proposed this incredibly clever fix, a split rounding strategy. For the forward pass, that's when the AI is making a prediction, they used a simple, stable method called round to nearest. But for the backward and update passes, where the AI is actually learning from its mistakes, they switched to something called stochastic rounding. It adds a tiny bit of randomness that, weirdly, stops biases from building up. This two-part trick was absolutely the key to making the whole thing work. All right, so we've got this incredible academic breakthrough, a proven recipe. But how does an idea like this actually get out of the lab and into the data centers that are running our world? Well, that's where it turns into a massive commercial bet from one of the biggest players in the game. And here it is. This is Nvidia's Blackwell. It's the first GPU ever built with hardware specifically designed to crunch these 4-bit numbers at lightning speed. This is the moment where all that theory becomes cold, hard reality. They took the concepts from that research paper and baked them right into the silicon. And NVIDIA's CEO, Jensen Huang, he's not being subtle about what this all means. He basically says the old way of doing things is over. Companies can't just use their old servers anymore. They have to completely rebuild their data centers with AI at the core. And for him, this new 4-bit capability, well, that's the cornerstone of this entire new architecture. So, why would a company re-architect everything? Well, this number on the screen, this is a pretty good reason. Moving from that old 16-bit standard to this new 4-bit NVFP4 format cuts your memory usage by about 3.5 times. That's insane. It means you can run way bigger models on the same gear or run the same models for a fraction of the cost. That is an absolute game changer. But of course, a story like this is never that simple, right? Moving from a clean research paper to a messy global product launch, there are always bumps in the road. And in the software world, those bumps often show up as a desperate bug report filed on GitHub. Okay, so check this out. It's a real-life developer detective story. So the symptom was a model using this new FP4 format just starts spitting out absolute nonsense, garbled text. The culprit? It turned out to be this totally normal function called torch.empty. All it does is grab some memory, but it doesn't bother to clean it out first, so it's full of leftover junk data. And here's the crime. This new FP4 format is so precise, so sensitive, that when it tried to convert that junk, it created an error called not a number, or NaN, which then poisoned every single calculation after it. The solution, thankfully, was super simple. Just switch to a function called torch.zeros, which makes sure the memory is clean. Crisis averted. It's just a perfect example of how a tiny detail can cause a massive headache with this kind of cutting-edge tech. And this whole saga, from the brilliant research to the shiny new hardware, all the way to a bug fix on GitHub, it all brings up a much bigger, much more important question for the entire tech community. When one company pushes a new standard forward this fast, is it just pure, unadulterated innovation, or is it something else entirely?
So, on one side of the debate, you've got this argument, which a user on Reddit put perfectly. The feeling is that AI is just moving way too fast for slow-moving committees and open standards. The argument goes that Nvidia is doing exactly the right thing. Just build it, push forward, and give the industry the tools it's desperate for right now.
But then, you have the other side of the coin. This user sees a pattern, comparing this new format to another NVIDIA-specific one from the past. And from this point of view, it's not just about innovation. It's a strategic play to create vendor lock-in, basically to build a beautiful, powerful ecosystem, a walled garden that's really, really hard for customers to ever leave. So this whole debate really boils down to a fundamental tension, a trade-off. It's speed versus control. It's about whether the incredible performance gains are worth the risk of being locked into one company's world. Can open standards possibly keep up, or is this just the new reality? These are the big questions everyone is asking right now. You know, when you take a step back, the story of 4-bit AI is basically the story of all modern tech in a nutshell. It starts as a brilliant spark in a university lab. It gets turned into a world-changing product by a massive corporation. It inevitably crashes into the messy reality of the real world with unexpected bugs. And then it ignites this passionate and frankly essential debate in the community about where we all go from here. Which leaves us with the one final massive question. Is this incredible new 4-bit format a true step forward for everyone? A rising tide that will lift all boats by making AI cheaper and more accessible? Or is it the beginning of a golden cage, a proprietary world so good, so powerful, that it becomes nearly impossible to escape? The answer to that is probably going to define the next decade of AI.